Scientists provide solutions for everyday life and help us to answer the great mystery of the universe. And with climate change looming on humankind and its existence, solutions to combat climate change are of utmost importance. On similar lines, Arvind Singh, who is an associate professor at the Physical Research Laboratory, Ahmedabad, is working on a potential solution that can trap atmospheric carbon in oceans. He is examining the role of enhancing ocean alkalinity for removing atmospheric carbon dioxide to tackle global climate change problems. Arvind explained how the increasing emissions of carbon dioxide in the atmosphere due to anthropogenic and other processes is a global problem that scientists are trying to tackle through various approaches.
So the idea is this. I mean, before we come to the idea, we know that the CO2 is a greenhouse gas. It has been increasing in the atmosphere for the last around 200 years due to the anthropogenic activities. And now the concentration of CO2 is already around 400 ppm. And that has a lot of consequences. They result in climate change that we all know. Many are unknowns, but we are quite sure that all the climate change is driven by the increase in CO2 concentration in the atmosphere. Now, as per Paris Agreement and also from the many policy point of view, it has been targeted that we need to restrict the global warming to below 2 degrees centigrade by 2100. Now, that restriction of 2 degrees centigrade is not going to happen even if we cut the CO2 emissions, which means that we need to not only cut the emissions, but we need to remove the atmospheric CO2. The CO2 which we have added, some part of that, let us say 50 to 60% part of that must be removed soon. And that soon means that should start within a couple of years or within 5 years. Now there are many methods, and one of such method is ocean enhancement. I mean ocean alkalinity enhancement. That if we increase the ocean alkalinity, there will be more pumping of CO2 from the atmosphere to the ocean.
Arvind further elaborated on the process of the experiment and how it will trap atmospheric carbon in the ocean.
It happens in nature, but that happens on a very slow process. For example, chemical weathering. In the weathering of rocks, these minerals they get deposited to the ocean, and the CO2 is being removed. But that happens on the geological time scale. That means on the time scales of thousands to million years of scale. Now we don't have that much of time to increase the ocean alkalinity. We have a very short time. So in this particular proposal of my DST Sound, all we are trying to do in some ways is trying to speed up this ocean alkalinity enhancement. So what we can do is that if we put some minerals, let us say olivine mineral in the ocean, that will increase the ocean alkalinity, that will produce some positive ions, for example, magnesium positive ions, sodium positive ions, and these positive ions will have to be balanced by the negative ions. Those negative ions are most likely to come from carbonate and bicarbonate. Now this carbonate, in many ways, the source of carbonate and bicarbonate is carbon dioxide. So once you form more carbonate and bicarbonate, that formation has to come from the CO2. So when the CO2 gets converted to carbonate and bicarbonate, there will be more CO2 going from the atmosphere to the ocean. This is just a gas. So if you reduce the partial pressure of CO2 in the water, there will be more pumping of CO2 from the atmosphere to the ocean.
The potential of the ocean is never a question. The only thing is the method. Which method is the best and how should we use the ocean to sequester carbon? Arvind is testing the hypothesis in the lab, and according to his hypothesis, the process has no potential harm to the ocean. But this is yet to be confirmed as the experiment will take shape.
Good point about this proposal is that most of the hypotheses that have been presented is that this may not have any negative consequence for ocean microbiology or even for the this may not have any negative effects, but this is a hypothesis, and this has not been tested in the lab set. In this particular proposal, we would also like to test that if we increase the ocean alkalinity, what kind of consequences that may have. Because nature is quite complex. Although we have hypothesized that nothing is going to happen or only the positive things will happen, but we do not really know. I mean, everything is one elemental cycle is linked to the other, and we do not really know. So, in a nutshell, this is all is.
The hypothesis, if successfully applied on large scale, can do wonders and will help the environment to fight climate change. Arvind also shared how the experiment is planned for future steps.
One is the fundamental questions like how this chemical weathering, these minerals get deposited, how this, I mean, to understand these processes, as well as this societal relevance or societal relevance would be a very small word to describe this because this has very large implications. Now come to the large scale. That means the ratio. Let us say if you want to add 1 unit of mineral, you will remove 2 to 3 units of CO2. So the ratio is like 1 to 2 or 1 to 3. And we let us say we want to right now through the anthropogenic activities, we have added almost 250 gigatons of carbon. CO2 will be much more, right? This is just the carbon in CO2. So 250 gigatons of CO2 we have added in the atmosphere. That means to remove, if we want to remove that all that 250, then at least the 100 gigatons of these minerals will need to be added. Now this 100 gigatons is a huge amount. Now how will that change? Why should that happen? How should that happen? I mean, these are the questions we are working in this proposal. These that I mean, this 100 is also a calculated number. This can also change because not the all the rocks that we will put in the ocean, they may all not get dissolved. It may not be 100% efficient. And then we have to do this in a step-wise process. That means although let us say our target is to remove 250 gigatons of CO2, but we have to go step by step. Let us say we target only 10 gigatons of CO2, right, removal. And for that we need to put around 2 to 3 gigatons of these minerals in the ocean. So this has to be step by step. But even to start that step, first we will need to do that experiment that I have proposed. We need to go on cruises to add these minerals in these small bottles and see how this affects the biology or the biochemical cycle. At the same time, the other part of my proposal is to see similar effects in the mesocosm experiment. Mesocosm experiments are slightly bigger. Of course, they can never be of the ocean scale. Ocean has 10 to the power 17 liter of water, so not I mean it can never be of that scale. But let us say 500. You take the 500 liters of seawater in a tank, and then you add these minerals. Then you monitor the evolution of biology, evolution of carbon and nitrogen cycling and phosphorus cycling for the 30-35 days, and see how this adding of minerals by a mean to increase the ocean alkalinity, how does it change the ocean biology.
Science has no boundaries, and to uplift humankind, every government is doing its best and collaborating where needed. Arvind shared his thoughts about the government and how they are uplifting science research in the country.
I think the government is putting a lot of money now, and there are a lot of changes from the policy point of view. And we have the new education policy at the same time, which is widely talked about. But at the same time, we also have a new science and technology policy that came up last year, so that is also in place. So the government, as far as I understand, they want to have a centralized funding agency, and then each institute or each university, these PIs can write to that particular agency. They can take grants from there. So this will be very streamlined. So that is one point. And also not only our government and the government all over the world, they now want to fund a project which has some kind of societal relevance. Of course, they are funding the fundamental science, which is like the most important part. They should keep doing that as well. But at the same time, each government has recognized that only doing fundamental science is not enough. And also because the fundamental science also leads to these implied science, but that takes a lot of time. First the discovery in the fundamental science, that is the gravitational waves and all, that was done long back, and now we are being used all those fundamental science discoveries. So that takes a lot of time, so we don't have that much time. We also need to have a project which have direct societal relevance. So all the governments all over the world, they are working in that direction.
India is a land of diverse stories, and Arvind said that inspiring stories should come out which will educate the masses, and the time to react towards climate change is right now. Thanks for watching and stay tuned for more such exclusive content.